Hi friends, welcome back to my channel. So how do you solve this integral? So I am going to solve this integral by rewriting this integral. So we can call our integral I. So I is going to be the integral from 0 to pi over 2 of sine 2x. I can write down as 2 sine x cosine of x times the tan inverse of sine of x as the angle dx. And what am I going to do here? I can rewrite this one as I is going to be the integral from 0 to pi over 2 of 2 sine of x, tan inverse of sine of x, and I'll bring the cosine of x all the way at the back and dx. So this one, I'm now going to do a u sub here. We can let u to be equal to sine of x. So du is going to be cosine of x dx. So in place of cosine of x dx, I can replace with du. And then the change in limits, when x is equals to 0, u is going to be sine of 0, which is 0. When x is equals to pi over 2, u is going to be sine of pi over 2, which is sine 90, which is 1. So let's take our integral from the x world into the u world. So I is going to be the integral from 0 to 1 of 2 sine of x is u, tan inverse of sine of x, which is u, and cosine of x dx is du. And what am I going to do here? Here I'm now going to do differentiation, integration by parts, I'm sorry. So D and I method, so D for differentiation, I for integration. I am going to differentiate the tan inverse of u and integrate to u. So differentiating the tan inverse of u is going to be, this is plus, this is minus, this is going to be 1 all over 1 plus u squared. And integrating to u is going to be u squared. So when we multiply terms diagonally, we are done with the integral, but when we multiply terms horizontally, we have to take the integral, right? This has become trivial now. So I is going to be the integral. So multiplying terms horizontally, diagonally, I mean, that is going to be u squared times the tan inverse of u, the limits from 0 to 1, minus the integral from 0 to 1 of multiplying terms horizontally. That is going to be u squared over 1 plus u squared du. So I is going to be u squared minus the tan inverse of u. I'm sorry, that is u squared tan inverse of u. Tan inverse of u. I'm not going to plug in the limits now. Minus this one, I can really do this by adding 1 and subtracting 1 to the numerator. And that is going to split this integral into the integral from 0 to 1 of 1 plus u squared over 1 plus u squared du. Plus, that's minus here and this minus here. That is going to be plus the integral from 0 to 1 of 1 all over 1 plus u squared du. So I is going to be u squared tan inverse of u from 0 to 1 minus this one will cancel out, and you are just integrating 1 plus the integral from 0 to 1 of 1 over 1 plus u squared du. So I is going to be u squared tan inverse of u from 0 to 1 minus, and this is u, integrating in the u world, that is from 0 to 1, plus this is the tan inverse of u from 0 to 1, that is integrating this one. So we can now really combine these terms. This is going to be u squared plus 1 all times the tan inverse of u minus u, all this one from 0 to 1. I'm just combining everything here. That is tan inverse of u, and tan inverse of u can be factorized out, and you have u squared plus 1 then minus u, and you are taking the limits of integration from 0 to 1. So let's plug in our limits now, really. So we have 1 squared plus 1 and the tan inverse of 1 minus 1. This is the upper limit minus the lower limit. You have 0 squared plus 1. All this one is multiplied by the tan inverse of 0 minus 0. This is the lower limit. So our integral I is going to be, this is 1 plus 1 here, which is 2 tan inverse of 1. Tan inverse of 1 is pi over 4. That is tan 45 minus 1. Minus, this is 1 tan inverse of 0 is 0 minus 0. So the lower limit is 0. So I is going to be pi over 2 minus 1. So this is going to be the value of our integral. Therefore, if we integrate, that is from 0 to pi over 2 of sine 2x, tan inverse of sine of x dx. This one evaluates to pi over 2 minus 1. So this is the value of our integral. So if you really find this helpful, make sure to hit the subscribe button for more tutorial from Calculus Diaries. I thank you so much for watching this video, and I will see you in the next one. Bye bye.